Okay, so imagine getting like a super accurate 10-day weather forecast.
Right.
But like in under a minute.
Wow.
That's kind of what we're diving into today, right? Like how AI is like revolutionizing weather prediction.
Mm-hmm.
And there's this tool called GraphCast, and it was created by Google DeepMind.
Okay.
We've got their blog post and the actual research paper right here.
Yeah.
It just came out in November 2023.
Oh, wow.
And it was even featured in Science.
Nice.
So our mission today is to like really understand how this thing works, why it's such a big deal, and what it means for the future of, forecasting.
Yeah.
Especially those extreme weather events that seem to be, happening more and more these days.
It's interesting because GraphCast, it isn't just like a small step forward, right? It's potentially changing the entire game of weather forecasting.
Yeah.
And being featured in Science, that's a big deal. It shows the scientific community is taking this very seriously.
It definitely seems like a major leap forward. But before we get lost in the technical details, right? I think it's worth remembering why we even care about accurate weather predictions, in the first place.
Yeah, absolutely. It's easy to just take weather forecasts for granted.
Totally.
I mean, they impact us constantly. From everyday decisions to huge industries, like agriculture.
Oh, for sure.
Knowing the weather is crucial for, well, obviously, transportation. And we can't forget emergency preparedness.
Right.
Like, how do we get ready for things if we don't know what's coming?
And with climate change, it's making extreme weather more frequent and more intense. Accurate forecasts are even more vital now, wouldn't you say?
Absolutely. I mean, the impact of hurricanes, floods, heat waves, early warnings can literally save lives, and help communities just prepare better.
Definitely, yeah. Okay, so we know why it matters so much. Now let's talk about how we traditionally predict weather.
Okay.
We've got this thing called numerical weather prediction.
Right.
Or NWP.
Right.
What is that all about?
So NWP has been the standard for decades. It uses these complex physics-based equations run on massive supercomputers to simulate the atmosphere and predict changes.
So it sounds incredibly complicated.
It is.
And it probably takes a lot of time.
Yeah, it does. While it has been effective, it requires a lot of computing power and time to generate those forecasts.
So it's accurate,
yes,
but slow.
Right.
How does AI change things with GraphCast?
So GraphCast takes a different approach.
Mm-hmm.
Instead of just focusing on physics, it's been trained on a massive amount of historical weather data. We're talking decades of information from the European Center for Medium-Range Weather Forecasts.
Oh, wow.
Or ECMWF, their ERA5 dataset.
Okay.
This dataset includes satellite images, radar readings, and ground-based weather station data.
So it's like GraphCast has learned from the past to predict the future.
Yeah.
Is that where the quote-unquote learning part of AI comes in?
Exactly. By analyzing all that historical data, it's identified patterns and relationships that humans might not even be able to see. And the key here is something called graph neural networks, or GNNs.
GNNs. Okay, now we're getting into the technical jargon.
Yeah, a little bit, but think of it this way.
Oh.
Imagine a social network, right?
Yeah.
Where each person is a data point, and their connections represent relationships. GNNs are designed to understand these relationships in data. Just like analyzing social connections can reveal trends in communities.
Okay.
Weather maps with their complex spatial data are kind of like those social networks.
Interesting.
And GNNs excel at making sense of them.
Okay, so it uses these GNNs to kind of sort through all that data.
Yeah.
What kind of results are we seeing with GraphCast?
Mm-hmm.
Is it actually faster?
Oh, yeah.
And more accurate?
The results are impressive.
Okay.
It can generate a 10-day forecast in less than a minute, using just a single Google TPU v4, which is a specialized AI chip.
Mm-hmm.
This is drastically faster than traditional NWP, which can take hours on a supercomputer.
Yeah. Wow. That's quite a speed boost. But what about accuracy?
Right.
Speed is great, but not if the predictions are way off.
Well, DeepMind's research showed that GraphCast outperformed the high-resolution forecast, or HRES system, which is considered the gold standard.
Wow.
And it did so on over 90% of the variables they measured across different lead times.
Oh, wow.
Even more impressive, it did exceptionally well in the troposphere.
The troposphere. Remind me what that is again?
Sure, that's the lowest part of the atmosphere, closest to the Earth's surface.
Right.
It's where most of our weather happens.
Makes sense.
So getting predictions right there is crucial.
Okay, so it's fast.
Yes.
And accurate.
Yes.
But how does it actually work?
Okay.
Can you break down the process for us?
It's actually quite simple. GraphCast takes a snapshot of the current weather and combines it with data from 6 hours ago.
Okay.
Using this, it predicts what the weather will be 6 hours into the future. It repeats this, rolling forward in 6-hour increments, building a complete 10-day forecast.
So each prediction builds upon the previous one.
Precisely. And what's even more fascinating is that GraphCast is particularly good at predicting extreme weather events, even though it wasn't specifically trained for that.
That's huge. We were just talking about the impact of extreme weather earlier.
Right.
Is this where GraphCast really shines?
It does. GraphCast's ability to, quickly and accurately forecast these events emerged naturally from its deep understanding of weather patterns, and it could be a game changer in preparing for those events.
So let's dive into some specific examples then. How has it performed with real-world extreme weather events?
Let's take Hurricane Lee back in September. GraphCast predicted its landfall in Nova Scotia 9 days in advance.
Wow.
While traditional models only converged on that location about 6 days out.
That extra warning time?
Oh, yeah.
That could be crucial for evacuations and getting resources in place.
Absolutely.
Yeah.
It gives communities more time to prepare and potentially save lives. And GraphCast is good at predicting other things, too, like atmospheric rivers.
Atmospheric rivers. Those are the bands of concentrated moisture in the atmosphere, right?
Yes.
The ones that can cause, like, massive flooding.
Exactly. Because GraphCast can accurately predict those. It can help with everything from flood warnings to managing water resources.
So it's not just about knowing a storm is coming. It's about understanding its intensity and where it's going to hit.
Right.
Is GraphCast going to replace traditional forecasting entirely?
It's more likely that the two will work together.
Okay.
GraphCast's speed makes it ideal for initial forecasts, which can then be refined using traditional methods.
That makes sense.
And there's another key aspect here. GraphCast is open source.
What does that mean exactly?
Google DeepMind has made the code publicly available, allowing scientists and weather forecasting agencies worldwide to use, adapt, and learn from it. Organizations like the ECMWF are already running live experiments with GraphCast and sharing those forecasts on their website.
That's incredible. So it's not just a research project that's already being used in the real world.
Right.
And the open source approach encourages collaboration.
Yes.
A faster progress, right?
Precisely. More researchers can build on this technology and find even more applications.
Yeah, that's great.
This collaborative spirit is essential, especially when dealing with something as critical as weather prediction.
So we've got this potentially transformative technology that's already changing the forecasting landscape. Where do we go from here? What does the future hold for GraphCast and AI in weather prediction?
Well, it seems like we're on the cusp of a real revolution in weather prediction, but maybe we could shift gears a bit.
Yeah, sure.
And talk about what this means, practically.
Yeah.
How could this impact our lives beyond just checking the weather app?
That's a great question. We've been talking big picture.
Right.
But how does this actually touch people day to day?
Right.
What are some real world applications for GraphCast?
One area where it could have a huge impact is renewable energy. As we transition to sources like solar and wind power, accurate forecasting becomes even more important.
Because those energy sources depend on the weather, right?
Yeah.
No sun, no solar power.
Exactly. Solar needs sunlight, wind power needs wind. Knowing exactly when and where these resources will be available, while that lets energy providers optimize their operations, improve grid stability, and make renewable energy more reliable.
So GraphCast could help us use those resources more efficiently.
Think about it. If we could predict cloud cover with incredible accuracy, solar power plants could adjust their energy output and storage, reducing reliance on fossil fuels.
That makes a lot of sense. Are there other industries where this level of weather prediction could be beneficial?
Agriculture is a prime example. Farmers depend on weather forecasts for everything. Planting, irrigation, harvesting, the whole works. GraphCast's accuracy in predicting, rainfall, temperature, even things like hailstorms could help farmers protect their crops, increase yields, and use resources more effectively.
So it's not just about knowing when to plant, it's about making the whole system more sustainable.
Absolutely. With better weather information, farmers can optimize water use, reduce pesticide use, and minimize the environmental impact of agriculture, which is crucial as we face climate change.
Speaking of climate change, could GraphCast contribute to a more sustainable future in other ways?
Definitely. Think about disaster preparedness and response.
Okay.
We've talked about its accuracy in predicting extreme events like hurricanes and floods.
Right.
That early warning capability is essential for saving lives and minimizing damage.
So it's not just about knowing a storm is coming, but understanding its intensity and path, being able to target resources where they're needed most.
Exactly. With GraphCast, emergency responders could make better decisions about evacuations, resource allocation, infrastructure protection. Imagine being able to predict the areas most likely to be affected by a flood. That allows for targeted evacuations and helps get aid where it's needed most.
It sounds like GraphCast isn't just a tool for predicting the weather, it's a tool for building a safer future.
And what's exciting is that we're just beginning to explore its potential. Researchers are looking into using it to predict air quality, which is a huge public health concern.
Being able to forecast pollution levels could help people take precautions to protect their health. It seems like the applications are almost limitless.
And remember, it's not just scientists benefiting from this.
Right.
Because GraphCast is open source, anyone with the technical know-how can use and experiment with it.
So communities could use it to fine-tune forecasts for their specific region.
Yeah.
Maybe even areas that don't have access to sophisticated weather forecasting tools.
Exactly. It could empower local communities to take weather prediction into their own hands using their knowledge of their specific environment. It's a powerful tool for adaptation and resilience.
It all sounds incredibly promising.
It is.
But, like with any new technology, there are always potential challenges. Are there things we need to be cautious about as AI plays a larger role in weather prediction?
Yeah, it's definitely exciting, but you're right. We should consider the potential downsides, too.
Yeah, for sure.
What kind of challenges do we need to be aware of as we kind of move towards this, AI-driven weather prediction?
Yeah, it's definitely exciting, but you're right. We should consider the potential downsides, too.
It's important to remember that AI is a tool, and like any tool, it can be misused.
Yeah.
Accurate weather information is valuable, so we need to be cautious about how it's used.
What do you mean? What are some potential risks?
Well, imagine companies using these, hyper-accurate forecasts for their own gain, maybe manipulating commodity prices, or getting an unfair advantage in the market. Those are things we need to think about.
Yeah, that's a good point. We don't want this technology to benefit just a few at the expense of everyone else.
Right.
It seems like ethical guidelines and regulations will be important as AI becomes more integrated into weather prediction.
Absolutely. We need to make sure this technology is used responsibly and for the benefit of everyone. And it's not just about ethical use. We also need to consider the broader societal impacts.
What kind of impacts are we talking about?
Think about jobs, for example. As AI systems become more sophisticated, what happens to the roles of human weather forecasters? How do we prepare for potential job displacement and make sure people have the skills they need in a world where AI is playing a bigger role?
Those are some serious questions we need to address as this technology evolves. It seems like AI and weather prediction brings up some really big picture issues, almost philosophical ones.
It does. For centuries, weather has been this force that we've tried to understand and predict, but it's always had this element of unpredictability.
Right, it's been something we've had to respect, adapt to. If we can now predict it with such incredible accuracy, does that change our relationship with nature? Do we start to see it as something we can control rather than coexist with?
That's a fascinating question. If we become too reliant on these predictions, do we risk losing some of that respect for nature's power?
Yeah.
Do we become complacent and think we can always outsmart the weather?
And what happens when the predictions are wrong, which is bound to happen at some point?
Right.
Could that lead to a false sense of security, making us more vulnerable when unexpected weather events do occur?
Those are all important points. But there's another side to consider too. Maybe this deeper understanding of weather patterns could lead to a greater appreciation for the interconnectedness of natural systems.
I hadn't thought about it that way. How so?
Well, think about how GraphCast works. It's not just predicting isolated events, it's modeling the entire Earth system, taking into account those complex interactions between the atmosphere, oceans, landmasses, even human activities.
So it's giving us a more holistic view of how everything fits together.
Exactly. And that could lead to a more profound understanding of how our actions impact the environment and reinforce the importance of things like climate change mitigation.
So instead of separating us from nature, this technology could actually bring us closer to it by showing us just how intricate and interconnected it all is.
Precisely. And it's not just about our relationship with nature. AI-driven weather prediction also raises questions about how we understand knowledge itself.
Okay, I'm intrigued. Tell me more.
We're used to gaining knowledge through observation, experimentation, developing theories. But with AI, we're entering a new era where knowledge can emerge from data, patterns, algorithms.
So the machine is teaching us things we didn't even know to ask.
Exactly. GraphCast wasn't specifically programmed to predict extreme weather, but it learned to do that by analyzing massive amounts of data.
Wow.
It makes you wonder about the nature of discovery, the role of intuition in scientific progress, and what it truly means to understand something.
These are some pretty profound questions. It makes you wonder where all of this leads. What's next for AI and weather prediction? What else might we be able to learn from these models?
Well, one area of active research is using AI to improve long-term climate projections. We're already seeing the impacts of climate change, so having more accurate predictions of how the climate will change in the coming decades is crucial.
So imagine going beyond tomorrow's weather and using AI to model the long-term effects of climate change on different regions of the world.
Exactly. It could revolutionize how we make decisions about things like infrastructure, resource management, even population displacement.
It's exciting and a little bit overwhelming to think about the possibilities.
It is. As we wrap up our deep dive into GraphCast, I think it's important to leave our listeners with a sense of wonder, but also a sense of responsibility.
So marvel at the technology, but also consider how we can use it wisely to shape a better future.
Exactly. And maybe the most important takeaway is that the line between natural and artificial is blurring. As AI systems become more sophisticated, they're not just mimicking human intelligence. They're starting to exhibit their own form of intelligence, one that can teach us things about the world that we might never have discovered on our own.
It's a thought-provoking end to our exploration of GraphCast and the future of weather prediction. I hope everyone listening will continue to think about these questions and have conversations about the role of AI in our lives.